El Niño is strengthening fast, and this time the signal is coming from thousands of miles across the Pacific Ocean. Right now, something is happening beneath the surface of the tropical Pacific that could influence weather across the United States months from now. The ocean is warming in a very specific pattern, the atmosphere is responding, and the latest forecasts from NOAA suggest that this El Niño could become one of the strongest events seen in decades. That does not mean America is about to experience one giant weather disaster. It does not mean every state will suddenly become hotter, colder, wetter, or drier. El Niño does not work like that. What it does is shift the odds. It changes where the atmosphere tends to send storms. It changes the position and strength of major atmospheric circulation patterns. And when the event becomes strong enough, those changes can influence winter weather across enormous parts of North America. The reason scientists are paying attention now is that the signal is becoming difficult to ignore. NOAA's latest assessment says El Niño is strengthening, with more than a 90% chance of a very strong event during the Northern Hemisphere fall and winter of 2026 and 2027. And that forecast is not based on one computer model. Scientists are watching the ocean itself. Sea surface temperatures across the eastern equatorial Pacific have already risen more than 2 degrees Celsius above average in some areas. In July, the Niño 3.4 index reached plus 1.4 degrees Celsius, while the Niño 1 plus 2 region in the eastern Pacific reached plus 2.9 degrees. Those numbers matter because El Niño is not simply defined as warm water somewhere in the Pacific. It is a coupled ocean atmosphere pattern. The ocean warms, the winds change, clouds and rainfall shift. Those changes affect atmospheric circulation, and the atmosphere then feeds back into the ocean. That interaction is what allows El Niño to grow. Think of the tropical Pacific as a gigantic engine. For years, the trade winds normally push warm surface water toward the western Pacific. That allows cooler water from deeper below the surface to rise farther east. But during El Niño, that system begins to change. The trade wind pattern weakens, or reverses in important areas. Warm water that has been stored farther west can move eastward. The eastern and central Pacific becomes warmer. Rainfall and thunderstorms shift eastward as well. And that movement of heat changes the atmosphere above the ocean. This is where the story becomes much bigger than the Pacific, because the atmosphere does not stay above one patch of ocean. Changes in tropical convection can influence atmospheric waves that travel thousands of miles. Those waves can alter the jet stream, and the jet stream helps guide storms across North America. So a change that begins in warm tropical water can eventually influence where winter storms travel across the United States. That is why scientists care about El Niño long before winter arrives. The ocean is giving them an early signal, and the latest signal is getting stronger. NOAA's August outlook gives a greater than 90% chance of a very strong El Niño during fall and winter. But there is an even more unusual number. For October through December 2026, NOAA estimates a 69% chance that the event reaches a historic strength category exceeding plus 2.5 degrees Celsius. If that happens, it would place the event among the strongest El Niño episodes in the historical record going back to 1950. That sounds dramatic. But there is an important distinction. A very strong El Niño does not automatically create extreme weather everywhere. Scientists are very careful about this. A stronger El Niño can increase the odds of certain impacts. It does not guarantee them. That distinction matters because the United States is enormous. A winter pattern that brings more rain to California can coexist with very different conditions across the northern plains. A stormier pattern in one region does not mean the entire country experiences the same thing. And that is one reason this upcoming winter could be so interesting. The effects of El Niño are regional. They depend on the strength of the event, the position of the jet stream, other atmospheric patterns, and what happens in the weeks and months surrounding the winter season. So what could Americans actually notice? One of the regions that often receives particular attention during strong El Niño events is the southern United States. The subtropical jet stream can become more active across the southern tier, creating conditions that favor more frequent storm systems in parts of the south and southwest. That can increase the odds of wetter than average conditions in some locations. But even here, the word odds is important. El Niño does not guarantee rain. It tilts the probability, and that difference between probability and certainty is one of the most important things to understand about seasonal forecasting. A forecast might say that a particular region has a higher chance of above-average precipitation. That does not mean every storm will hit that region. It means the overall atmospheric setup makes that outcome more likely than it would otherwise be. California is another region worth watching. Strong El Niño events have historically been associated with shifts in winter precipitation across parts of the West, particularly California. But even here, the result can vary from event to event. A strong El Niño can increase the potential for storminess, but the exact position of the jet stream determines where those storms actually go. And that can make a huge difference. A storm track a few hundred miles farther north can completely change the outcome for a particular city. One region could receive heavy precipitation while another remains relatively dry. That is why scientists do not simply look at El Niño strength and declare what the winter will look like. They combine the El Niño signal with other atmospheric information. And there is another reason this event deserves attention. The ocean is not warming only at the surface. NOAA's latest observations show unusually warm water extending below the surface of the equatorial Pacific. In July, subsurface temperature anomalies reached about 10 degrees Celsius above average at depth in some areas. That does not mean the entire Pacific Ocean is 10 degrees warmer. It means there are localized subsurface areas with exceptionally large temperature departures. That hidden heat matters because subsurface water can help sustain and strengthen the surface El Niño pattern. Think of it as stored energy beneath the ocean. You cannot see most of it from the surface, but it can influence what happens next. And this is one reason the latest forecasts have become more confident. The ocean is showing the signal, the atmosphere is responding, and the computer models are increasingly agreeing on the direction of the pattern. NOAA's official outlook indicates that El Niño should continue strengthening through the end of 2026. The current forecast also shows the event remaining strong into the winter. That means this is no longer simply a possibility scientists are watching from a distance. It is an active climate pattern already developing. But there is another question. If El Niño is strengthening, does that mean winter 2026-27 will be colder? Not necessarily. This is one of the biggest misconceptions about El Niño. El Niño is not simply a cold winter or warm winter switch. It can actually produce different temperature outcomes in different parts of the country. The southern tier can experience periods of cooler conditions during certain setups, especially when clouds and precipitation are more frequent. But long-term temperature trends can offset or modify that signal. Other atmospheric patterns can interfere with or amplify the El Niño influence, and the northern part of the country can experience an entirely different pattern. So instead of asking whether El Niño will make America warmer or colder, a better question is, where will El Niño change the odds? That is what seasonal forecasters are trying to determine. And it becomes particularly important when you look at precipitation. Water is often where the consequences become more significant. A stormier winter can affect reservoirs, snowpack, agriculture, wildfire conditions, and water supplies. In the West, additional precipitation can be beneficial after dry periods. But too much precipitation arriving too quickly can also create flooding problems. Mountains add another layer of complexity. If precipitation falls as snow at high elevations, it can be stored for months and gradually released as temperatures rise. If temperatures are too warm, the same moisture may fall as rain instead. So the exact temperature of the atmosphere can determine whether a storm becomes a beneficial snow event or a dangerous rain event. This is why the phrase El Niño means more rain is far too simple. The real story involves storm tracks, elevation, temperature, snow levels, soil conditions, and timing, and those factors can change from week to week. Another important consequence involves the Pacific coast. NOAA researchers are already watching warmer than normal ocean temperatures along portions of the west coast. Marine ecosystems respond to these changes. Fish distributions can shift. Ocean temperatures can influence marine heat waves. And coastal communities can face additional complications when warmer ocean conditions interact with seasonal weather patterns. There is even another effect that most people never think about: tides. NOAA has warned that El Niño can contribute to higher sea levels along parts of the U.S. West Coast, potentially increasing the risk of high tide flooding in some coastal communities. Again, El Niño does not create one giant wave or one massive coastal disaster. It changes background conditions. And when those background conditions combine with high tides, storms, and local geography, the consequences can become more noticeable. This is what makes climate patterns so fascinating. The most important changes are often invisible. There's no giant line moving across the sky announcing that El Niño has arrived. Instead, there are subtle changes in ocean temperature, changes in wind, changes in pressure, changes in rainfall, changes in atmospheric waves. And eventually, those changes can influence weather thousands of miles away. That is why scientists monitor El Niño continuously. Satellites watch the ocean, buoys measure temperature and currents, weather stations monitor atmospheric conditions, ocean instruments measure what is happening below the surface, and computer models combine all of that information. The goal is not to predict the weather on one particular day 6 months from now. That would be impossible. The goal is to identify large-scale patterns that persist long enough to influence seasonal probabilities. And right now, one of those patterns is becoming unusually strong. The latest NOAA outlook does not say America will experience one specific winter. It says the odds are changing, and the stronger El Niño becomes, the more confidence scientists can have in some of those broad statistical patterns. That is an important distinction. Seasonal forecasting is not fortune-telling. It is probability. Imagine rolling a loaded die. You still do not know exactly which number will appear, but if one side has become more likely, you can say something meaningful about the odds. El Niño works in a similar way. It loads certain atmospheric outcomes. It does not determine every individual storm. That is why two strong El Niño winters can still look very different. The background pattern may be similar, but the details are never identical, and this particular event is still developing. That means scientists will continue updating their forecasts as new observations arrive. The current numbers could change. The strength could peak earlier or later than expected. The atmospheric response could become stronger or weaker, and regional impacts could shift. That uncertainty is normal. In fact, it is exactly why the forecasts are updated. But there is one thing that is becoming increasingly clear. The Pacific is no longer behaving neutrally. El Niño is here, and according to NOAA, it is strengthening. The latest observations show the ocean and atmosphere working together in a way that is consistent with a developing strong El Niño. The forecast models are pointing in the same general direction, and winter is still months away. That gives scientists an unusual opportunity. They can watch the event develop in real time. They can measure how the ocean changes. They can see how the atmosphere responds, and they can compare the developing pattern with previous strong El Niño events. That comparison could become especially valuable if the event reaches historic strength. Because a very strong El Niño is not just interesting because of the number on a temperature chart. It becomes an opportunity to study how an enormous climate system behaves when the ocean-atmosphere connection becomes exceptionally powerful. And for people across the United States, the important question is not whether winter will be bad. The better question is where the odds are shifting. Will California see a more active storm season? Will parts of the South experience a wetter pattern? Will the northern states experience a different temperature setup? How much snow will fall in the mountains? Where will the jet stream settle? And how will other atmospheric patterns interact with El Niño? Those are the questions scientists will be watching as autumn approaches. And there is a good reason to pay attention before winter arrives. By the time the most obvious weather effects appear, the Pacific Ocean may have been signaling them for months. The ocean is slow compared with the atmosphere. It stores enormous amounts of heat. And once a large-scale pattern develops, it can influence atmospheric circulation across an entire hemisphere. That is why something happening near the equator can eventually affect someone living thousands of miles away. A warmer patch of ocean can alter thunderstorms. Those thunderstorms can alter atmospheric waves. Those waves can influence the jet stream. The jet stream can redirect storms. And those storms can determine whether a region receives rain, snow, or relatively little precipitation. It is a chain reaction. And right now, that chain is becoming stronger. But there's no reason to panic. The strongest El Niño events in history have not produced identical impacts everywhere. Even NOAA emphasizes that stronger events increase the chances of expected impacts, but do not guarantee them. That is the responsible way to look at what is happening, not as a countdown to disaster, not as a guarantee that America will experience extreme weather, but as a major natural climate pattern that could reshape the probabilities of winter weather across large parts of the country. And over the next few months, the most important story may not be what happens in the atmosphere above America. It may be what happens in the Pacific Ocean. If the warm water continues strengthening, if the atmospheric circulation remains coupled to the ocean, and if the forecasts continue pointing toward a very strong event, the winter signal will become increasingly difficult to ignore. The Pacific will keep sending signals, scientists will keep measuring them, and eventually the atmosphere over North America will respond. So when winter finally arrives, the weather you experience may seem local. A storm moving across California, rain falling across the south, snow building in the mountains, a warmer or colder week somewhere in the country. But behind those individual events could be a much larger pattern that began thousands of miles away in the tropical Pacific. That is the real story of El Niño. It does not control America's weather. It does not guarantee a particular outcome, but it can change the odds. And this time, the signal is getting stronger. NOAA currently gives greater than a 90% chance of a very strong El Niño during the Northern Hemisphere fall and winter of 2026 to 27. There is also a 69% chance that the October through December period reaches a historic strength threshold. Those numbers are forecasts, not promises. But they are strong enough that scientists are paying very close attention. And as the Pacific continues to warm, the next few months will tell us just how unusual this event becomes. If you want to follow the major changes scientists are detecting across Earth's atmosphere, oceans, geology, and climate while they are still developing, subscribe to Wide View. Because sometimes the biggest changes do not begin above our heads. They begin thousands of miles away, hidden beneath the surface of an ocean. And right now, the Pacific is sending a signal that America may feel this winter.